So students, we are back with another video today. We did addition of matrices last time. Today we would be learning multiplication of matrices. As I told you last time, matrices is a new topic that you have learned. So we did addition, subtraction and scalar multiplication of matrices. We did 3 operations on matrices. Today we would be learning is multiplication of matrices. Now multiplication of matrices is not easy. How do you multiply any two particular matrices? Say for example, if you have a matrix A as 1, 2, 3, 4 and you have a matrix B as A, B, C and D. So now how do I perform matrix multiplication? It's easy, simple. 1A, 2B, 3C and 4D. Done with matrix multiplication. No, this is absolutely wrong. This is how we do not perform matrix multiplication. Now to do matrix multiplication, there are certain rules that we have to follow. We cannot multiply all kinds of matrices also. To multiply also, there is a particular rule which we need to follow. Now the first rule for matrix multiplication. Rule for matrix multiplication is number of columns of first matrix. Number of columns of first matrix should be equal to the number of rows of the second matrix. So the first rule is number of columns of first matrix should be equal to the number of rows of the second matrix. For example, if I have A as Aij M cross N and I have B as Bij N cross P. I have A as Aij M cross N and I have B as Bij N cross P. Now my first rule to multiply, what did I tell you? Number of columns of first should be equal to the number of rows of second. So that means the number of columns of first and the number of rows of second are equal over here. So I can perform matrix multiplication. Now when I perform matrix multiplication, the resulting matrix that I would get is Cij, which would be what? M cross P. Cij would be equal to M cross P. So the resulting matrix that I get, resulting matrix for matrix multiplication is what? Number of rows of first into number of columns of second. That gives me the resulting matrix. So please do remember these two rules over here. The resulting matrix is number of rows of first is equal to number of rows of first into number of columns of second. That gives me the resulting matrix. So here were my two conditions to multiply. First condition was number of columns of first should be equal to number of rows of second, and the resulting matrix that I get is number of rows of first is into number of columns of the second matrix. Now I'll show you how we perform matrix multiplication. As I just now told you, how do we multiply two matrices? If A is Aij M cross N and B is Bij N cross P, then the condition to multiply is number of columns of first should be equal to number of rows of second, and the resulting comes out to be number of rows of first into number of columns of second. So I get AB as Cij, which is M cross P. Now how do we perform multiplication? The order of this matrix is a 2 into 2 matrix and this is a 2 into 3 matrix. So first of all, let us see, can we perform AB over here? This is my A matrix and this is my B matrix. So let's check for the condition first. Number of columns of first is equal to number of rows of second. So yes, I can perform matrix multiplication over here. Now how do I perform matrix multiplication? First row into the first column gives me the first element. Please do remember, first row into the entire first column gives me the first element. From the first row, first matrix, we would be only taking the rows, and from the second matrix, we would be only taking the columns. So this is what? 1 into 1 plus 2 minus 2 into 2. This gives me the first element. Now I have completed first row, first column. I move ahead now. First row, second column. So first row, second column gives me what? 1 into 2 plus minus 2 into 3. So now I still have one more column. If I had only 2 columns, I would have stopped over there. But I further have one more column. So now first row, third column. So this would be now what? 1 into 3 plus minus 2 into 1. So this has completed my first row over here. It has 3 columns. Now I move to the second row. Second row, first column. So 2 into 1 plus 3 into 2. Now second row, second column. So 2 into 2 plus 3 into 3. Now second row, third column. 2 into 3 plus 3 into 1. So now if you see, now I do not have any row further, so I will have to stop over here. So what kind of a matrix I have got? I've got a 2 into 3 matrix, which is what? Number of rows of first and number of columns of the second matrix. So please do remember, first matrix I only have to take the rows, and second matrix I only have to take the columns. I once again repeat, how do I perform matrix multiplication? First row into the entire first column would give me what? The first element. Please do remember the first element. Then first row, second column would give me the second element. So let's see what's the result that I get. 1 minus 4. So then what? 2 minus 6. 3 minus 2. 2 plus 6. 4 plus 9. And 6 plus 3. So the final answer that I get over here is minus 3 minus 4, 1, 8, 13 and 9. So I have got a 2 cross 3 matrix with this particular answer. So this is my final answer. So that is how I can multiply any 2 matrices. Now, generally you know that 2 into 3 and 3 into 2 are the same. So like I did AB over here, can I do BA over here? BA would also give me the same answer. No, I cannot perform BA over here. Why? See the order of the B matrix. The B matrix is a 2 into 3 matrix, and the A matrix here is a 2 into 2 matrix. So I cannot perform multiplication over here because the number of columns of first and number of rows of second are not the same. So BA is not possible in this particular case. BA is not possible in this particular case. So this is something very important. Matrix multiplication is not commutative. AB may be equal to BA. AB may or may not be equal to BA. Maybe sometimes yes, AB and BA come out to be the same, but sometimes they are not possible and sometimes they are different. So matrix multiplication is not commutative. So that is how we perform multiplication over here. We'll take up another question. So now we take up another question on matrix multiplication. Okay, we need to perform AB over here. If you see the order of this matrix, this is what? 3 into 1 matrix, and this is what? A 1 into 3 matrix. So let us perform matrix multiplication. So what is AB that we get from here? 1 into 2 plus 2 into 3 plus 3 into 4. So AB, what I get from here is 2 plus 6 plus 12. So 20 is the answer that I get from here. This is absolutely wrong. Please do not do matrix multiplication like this. What did I tell you? First of all, you would see how I would perform multiplication. Number of columns of first and number of rows of second. Yes, they both are equal. And what kind of a resulting matrix is I would get? The resulting matrix would be number of rows of first into number of columns of second. That gives me the resulting matrix over here. So the resulting matrix, now how do I multiply? First row into first column gives me the first element. So 1 into 2. Then what? 1 into 3 and 1 into 4. First row, first column gives me the first element, first row, second column gives me the second element, and first row, third column gives me the third element over here. Now we move ahead to the second row, first column. So that would be what? 2 into 2. Then second row, third column. So what would that be? 2 into 3. Then second row, third column. So that would be 2 into 4. Now we move to the third row, first column. So 3 into 2. Now third row, second column. So what would that be? 3 into 3. And then third row, third column. So 3 into 4. So see what kind of a matrix we have got. We have got a 3 into 3 matrix over here. That is 2, 3, 4. 4, 6 and 8. 6, 9 and 12. So I have got a 3 into 3 matrix over here. So that is how I perform matrix multiplication over here. Now again you can try, is BA possible over here? You can see that. Let us take up another question over here, same on matrix multiplication. This was question 3, second part, exercise 3.2. Now, suppose I take up exercise 3.2, same question, question 3, the sixth part. Now, I have a matrix A as 3, minus 1, 3, minus 1, 0 and 2. And always write the matrices in front of each other. If you want to perform multiplication, do not write one below the other. You will tend to make a mistake. So always write the matrices in front of each other to perform matrix multiplication. So A is this matrix and B is 2, minus 3, 1, 0, 3 and 1. So this is the two matrices that I have over here. Let us see the orders first. First do mention the order. So this is a 2 into 3 matrix and this is what? 3 into 2 matrix. So yes, I can perform matrix multiplication as number of columns of first and number of rows of second are same. And what kind of a resulting AB would I get? I would get a 2 cross 2 resulting AB. So let us see. First row into the entire first column would give me the first element. So let's see, 3 into 2 plus minus 1 into 1 plus 3 into 3 gives me the first element. Now what? First row, second column. So 3 into minus 3 plus minus 1 into 0 plus 3 into 1. Now I do not have a third column, so I will have to stop over here. Now I move to the second row. Second row, first column. So minus 1 into 2 plus 0 into 3 plus 2 into 3. Now second row, second column. So minus 1 into minus 3 plus 0 into 0 plus 2 into 1. So see here, I have got a 2 cross 2 matrix. Now when I perform my calculation, what's the answer that I get? I get 14, 3 into 2, 6 plus 9 minus 1. So I get 14 minus 6, 4 and 5 over here. So that gives me my required particular answer. So that is how you perform matrix multiplication over here, just normal calculation. And as I said earlier, please do remember, first matrix you have to take the rows, and second matrix you have to take the columns. So first row, first column, first row, second column has given me the first row. Then second row, first column, second row, second column has given me the second row. So that is how I have got my AB matrix.